Hi everyone, my name is Tarik Roukny. I'm from University of Leuven and I'm very happy to present this joint work with Christoph Aymanns and Mathias Dewatripont. Many thanks to the organizers for including this paper in the program. It's a very exciting program to be in. So the motivation for this paper starts from the current state of many platform markets and businesses where a few entities dominate and accumulate huge market power. For example, in credit card payments in Europe, almost 90% of the activity is controlled by two companies, Visa and MasterCard. A major feature driving this outcome is the presence of large network effects, which typically mean that consumers are driven to the same platform in order to enjoy larger sets of interactions. While this situation is not new and has already caught the attention of policymakers and academics for several years, innovation in the field of distributed ledger technology is sparking new hopes that we can address market power and network effects through a new model of platform governance. So here what we mean by distributed ledger technology is simply any technology that allows a group of agents to coordinate on a common state of the world without the need of an intermediary. While our approach is quite generic, you can typically think of blockchain as being a prime example of such technology. So to be a little bit more precise, here's a quote from Catalini and Tucker, who stated in 2018 that, in theory, blockchain technology can be used to overcome the coordination challenges that otherwise lead network effects to be a source of market power. So in this paper, this is exactly what we want to test. So we propose to formalize this new model of platform governance as a form of vertical disintegration. Traditional platforms like payment systems create value by allowing buyers and sellers to transact, as is shown in this figure. However, the underlying infrastructure of the platform is usually owned by the platform itself. The provisioning of the service is built in-house and the platform maintains full control over prices. So you can typically think here of companies such as Visa, MasterCard, and American Express. In contrast, payment systems like Bitcoin do not own the infrastructure. The provisioning of the service is provided by a market of processors who compete to process the transactions between buyers and sellers. The price is now determined by a market clearing between processors and a set of users. And so the question we're after is, what are the welfare implications for users of such disintegration? And in the case of payments, what specific designs should be implemented in order to maximize adoption and financial inclusion? So we do address this question by basically comparing the integrated model, traditional one, which we refer to as a VIP, vertically integrated platform, and the disintegrated model, which is made possible now with the distributed ledger technology, which we will refer to as VDP, vertically disintegrated platform. So in order to address this question, the model we construct is shamefully simple. We extend the classic two-sided platform model of Rocher and Tirole by introducing this new market for processing users' interaction. So we basically have buyers and sellers who extract utility from interacting on the platform. They also have to pay a transaction fee that is specific to their types. So the buyer is going to pay AB per transaction and the seller will have to pay AS per transaction. The new agent class that we introduce in the model is those processors who make profit by processing transactions. For each transaction they process, they earn a share of the aggregate price Y minus T. This aggregate fee is going to be integrated by P. And they have a cost, and this cost is driven by their processing technology, which is drawn from a known distribution. Finally, we have the platform, which allows this interaction between buyers, sellers, and processors, and generate potentially revenue by charging a tax on each of these transactions. That was the value T. The platform maximizes profit via two variables, this tax charge on transaction, and the split of the transaction fee, the total transaction fee, between buyers and sellers. So here Z indicates the price structure. It determines how much one side may be overcharged in order to subsidize participation of the other side. For example, in the credit payment systems, merchants typically pay more per transaction than consumers. The profit of the platform is then determined by this total revenue and a fixed cost C of establishing and maintaining the platform. At the market level, our measure of welfare will be driven by the total participation from the users, so NB for the number of buyers and NS for the number of sellers. And the market clearing mechanism here is the aggregate price P that satisfies the demand from users, buyers and sellers, and the supply from processors. So once we've established this model, our analysis will then consist of comparing the outcome of this disintegrated model with its integrated counterpart, which ends up being very close to the Rocher and Tirole original model. So here, once again, buyers and sellers are the same as in the Roukny and Tirole model, but now processors do not exist anymore. And we assume that the platform basically integrates the full technology infrastructure that previously belonged to the processors. So the cost distribution is similar, but now the platform has full knowledge over it and can fully control both prices level, P, and price structure, Z. The platform collects all the revenue from transaction fees, and similar to before, it faces an additional cost C. However, in contrast to the disintegrated case, we will also consider cases where this cost can be affected by the transaction volumes. I will elaborate on this in the results section. And finally, at the market level now, we do not have a market clearing condition anymore, as all pricing is being determined by the platform itself. Now for the result. Our plan for the result is basically to compare two cases of monopoly platform, one in which there is only a VIP and another one in which there is only a VDP. We do so in order to maximize users' benefit from network effects and therefore focus on the precise welfare implication of disintegration in the extreme case of no platform competition. We first study the effect of disintegration on the price structure, and we then run a welfare analysis by proceeding incrementally, starting from the simple setting and progressively adding new ingredients. So for the price structure, what we know first is that the price structure strategy of a multi-sided platform has been widely analyzed in the literature. A major result from the literature is that when different sides exhibit different elasticities of demand, it is efficient for the platform to charge each side differently. So now recall that the VIP maximizes profit by setting both the price structure Z and the price level P, whereas the VDP only has control over Z. So the price level P is here set via the market for processors. However, our result here is that given the same price level P, both platform models achieve the same price structure Z. This results from the fact that in the VDP case, the supply from processor is independent from the price structure, from Z. So the platform can therefore always increase its profit by raising the level of demand at any price level. So both platforms end up converging to the same price structure that maximizes demand. This result is basically valuable for two reasons. First, it allows us to focus the welfare analysis on price levels, so on P, now that we know that both models of platform achieve similar price structures. And second, it shows that previous results on multi-sided platforms directly apply to the analysis of disintegrated platform. In particular, the adapted learner formula, which determines efficient pricing for multiple sides, applies and allows us to have a welfare judgment on the design of current VDP applications, and we will just do that in the next section. So now that we have knowledge about the effect on price structure, we can move to our first welfare analysis. So in this case, we make two simplifying assumptions, which we will then relax. First, we assume that both VDP and VIP face a similar cost structure. And second, we consider an exogenous tax for the VDP. In this case, what we find is that the welfare under the VDP dominates if the tax set by the VDP is lower than a tax benchmark TI. This benchmark tax is obtained from the following analysis. First, note that the tax charged by the platform influences total supply. Lower taxes increase the supply curve. Hence, for a given price set by the VIP, PI, we can always find a tax value TI that the VDP should set in order to replicate the price of the VIP. Once this TI is determined, we know that any tax that is lower than this value would yield a higher supply, then lower prices, resulting in higher welfare. The next thing we do is we endogenize this tax. And so what happens when we endogenize the tax is that we find that if the VDP is left to choose the tax that maximizes its profit, welfare under the VDP will be lower compared to the welfare result from the VIP. The reason for this stems from the information disadvantage of disintegration. In fact, the VDP does not observe a marginal technological cost from the processors, and because of the linearly priced tax power that it has, it cannot extract all the surplus from the processors. In contrast, on the VDP side, by owning the full technology, the VIP fully observes all these costs. So the VDP has to compensate for this disadvantage by imposing higher tax per transaction than the benchmark tax TI that would replicate what the VIP would impose. Now, armed with these two results, we can formulate a policy recommendation derived from the following corollary. If an upper limit is set to the taxing capacity of the VDP, such that taxes charged on the processors cannot be higher than TI, welfare under this regulated VDP will dominate the VIP outcome. Note that an interesting parallel here is that the VDP acts effectively as a monopsonist in the market for processors. Hence, this result acts much like minimum wage intervention in traditional labor markets. So now finally, what we want to do is we want to explore what happens when we have differential cost structure per platform. So we now allow the cost structure of the integrated platform to be a function of the total transaction volume. Now, not surprisingly, we find that if the growth rate becomes significant, welfare under the VDP will dominate even without any intervention on its taxing capacity. So this result is simply driven by the fact that as cost increases with demand, the VDP will reduce demand by increasing prices, effectively increasing the benchmark tax TI, which will become larger than the endogenous tax T of the VDP, which remains basically the same even with changes in demand, as the VDP does not suffer from increased cost by virtue of the market clearing process, which allows processors to fully absorb changes in the total demand. So the reason why we studied this last section is driven by existing distinction in real platform businesses models between closed-loop systems and open-loop systems. Open-loop systems include Visa and MasterCard and partially rely on the infrastructure of the banking system. Accounts are held by banks and not by the network, which mainly consists of messages passing between banks. Such architecture is capital light, and we can cast it to the original set of assumptions where the cost structure between the VDP and the VIP were considered equivalent. So this would allow us to map it to the three first results we've presented. In contrast, in a closed-loop system, the company owns the full infrastructure and the accounts associated with each participant. This is typically the case for American Express. This business model is much more capital-heavy compared to the open-loop system. In particular, costs associated with adapting to the demand are directly borne by the platform. So this VIP setting here is therefore relevant for our last result when it comes to the effect of transaction volumes on the cost borne by the platform. Now, armed with this framework and results, we can derive welfare implications and recommendations from current applications. So the first ones we look at are Bitcoin and Ethereum, which represent the main current form of disintegrated platform using blockchain technology. Our approach is particularly interested in the design choices of these cryptocurrencies as payment platforms. So here we abstract from the token dimension of these platforms. So from our perspective, this platform can be seen as zero tax platforms. Nothing is charged on the processors by the platform. No revenue is derived from the transactions either. According to our result, low taxes are good for welfare. However, these platforms have a precise price structure design, which makes the buyer pay the full price of the transactions. In our model, this corresponds to Z equal to P over 2, and by virtue of the price structure result and the literature on multi-sided platforms, we know that platforms increase welfare by setting the price structure according to the elasticities of demands from both buyers and sellers. Typically, in a retail setting, merchants and consumers exhibit very different demand profiles. And if you take the example of credit card markets, merchants pay more than consumer per transactions. The failure of the price structure design in Bitcoin and Ethereum to account for multi-sidedness may ultimately harm welfare and constitute a major barrier for global adoption. Finally, we believe our result can also inform the current debate over central bank digital payments and central bank digital currencies. According to our framework, a CBDC, a central bank digital currency that would be supported by a regulated VDP governance model, would be welfare maximizing because it would both ensure the capability to adjust the price structure efficiently and at the same time limit the tax level charged on the processors. Such a solution would allow governments to implement central bank digital money or other forms of payment solution without bearing the traditional enormous investment costs and maintenance efforts. Okay, so let me conclude. Our hope with this paper is to broaden the debate about platform market power and welfare by investigating new forms of platform governance made possible by the introduction of distributed ledger technologies such as blockchain. We basically study a technologically driven market solution to the issues of market power in presence of network effects in the form of vertically disintegrated platforms. We find that the desirability of this integration is determined by, on the one hand, the cost structure faced by the integrated solutions, and on the other hand, the market conditions for processors and the taxing capacity of the platform in the disintegrated case. We also find that the price structure result from traditional platforms apply in the case of disintegrated platforms, suggesting they need to be taken into account in future applications. We also show that our framework can generate simple welfare implication of current applications and designs such as Bitcoin and Ethereum, but it also provides guidelines for regulation and design policy for future platforms, including central bank digital currencies and central bank digital payments. All right, so let me stop here. Thank you very much for your attention, and I really look forward to your comments and feedback.